Hello, everyone. Today we're going to discuss Benedoc, Tarski, Baradoc. With that, I'll turn the subject to my grandson, Tristan.
All right, thank you. So last time I know we discussed the problem of a countably infinite number of sequences stemming from a starting point not being able to map the uncountably infinite amount of unique points that exist in a sphere. Now today I'm going to discuss how to solve that problem. And it's a pretty simple solution. It can be solved by mapping an uncountably infinite amount of starting points and drawing countably infinite sequences from those. So these countably infinite amount of starting points, they'll be able to map a lot of countably infinite directions and unique points stemming from those directions to the point where, for all intents and purposes, the sphere might as well just be filled up in an uncountably infinite fashion. So with this solution, of course, the sphere isn't technically uncountably infinitely filled up, but we might as well just say it for the sake of argument. Now, the thing is, from this new complete sphere that we've completely mapped out, we'll have a lot of different names for our unique points. So we'll have the names left, right, up, down, and then we'll have the center points and the poles. And we can divide these into 6 groups based upon what their name is. And of course, their name is the direction that the sequence ends in. So let's focus specifically on the left group, or the left part of the circle. Now, we can do something kind of cool here and take this left part of the circle and rotate it right. Now, the thing is, this will result in a backtrack, which I've already said that's, not valid. So that means that the left and right parts of the left part of the circle will kind of cancel each other out. And that'll mean that because these two parts are canceled out, that means we'll be left with the left, up, down, and the starting points that are contained within the sphere. So you see, if we rotate it right, the left part, if we rotate the left part right, then it'll cancel out the sequences that end solely in left, and it'll make it so all these other different rotations are named. So as you can see, by utilizing the methods of the Banach-Tarski paradox, we've changed just one part of this 6-part circle into most of the complete circle, right? And to finish this completion, to complete the actual sphere, all you would need to do was add in the right points and the center points, and you add those two together, and that's the complete sphere. But sorry, you also need to add in the poles. Sorry about that. The thing is, you have a complete sphere, right? But the thing is, you haven't used all the parts that you got from the original sphere, so there are still parts left over, right? Now, the thing is, let's focus specifically on the up part of the sphere. Now, to generate a complete circle out of this, or a complete sphere, sorry, to generate a complete sphere out of this, all you need to do is take notice of all the sequences, the set of sequences that are just like a string of ups. So any sequence that is just like up, 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 you just need to get that into one group, all those sequences that are just solely ups. And what you need to do is you need to add that to the right parts of the sphere. Now, after this is done, this means that you can rotate the up sphere down and do the same thing that you did for the left sphere earlier. And then this will result in a almost completed sphere again. All you need to do is add in the right part of the sphere with all the down points. And I want to discuss this real quickly. If you add all those up points, if you add those infinite sequence of solely up points to the right points, then that will cancel out some of the parts of the right parts of the sphere.
Mm-hmm.
And this will mean that these parts that canceled out, this means that, they're going to be completely wiped away. So that means that we're going to have parts left over. And from those parts, we'll generate starting points that can generate new parts. So by adding this series of ups to the right part of the sphere, we've also generated starting points as well. Now, all you need to do is add the starting points to this second sphere and complete the sphere of starting points with the pre-added sphere of starting points, and add the rotated up sphere to the right sphere that has this completed circle of starting points, and you've almost got the full sphere again. But the thing is, we have a problem. The center and poles are missing from this new sphere, right? But the thing is, there's a pretty easy solution to this again. So what we can do is we can go into this new sphere, and we can just do the same method that we did earlier to determine the center points and the poles. We can just add starting points in this second sphere and generate points from that. And from those points that are generated, we can factor in the center and poles. And this is kind of the essence of the Banach-Tarski paradox. It demonstrates a way that you can mathematically, at least, create two different spheres, two separate 3D objects, by decomposing parts of one 3D object. So that would essentially wrap up the subject.
Thank you for watching.